These are the solutions to exam 2, semester 2, 2019. Let's have a look at the questions. Okay, we'll jump over the multiple choice and do the analysis first. So we've got a quartic function here, f of x equals part of the graph, and we want to get the derivative. Well, look, we're going to use that, I presume, a lot. So let's get straight into it and define f of x equals 3x to the 4 plus 4x to the 3, take 12x squared. And whilst it's not a terribly difficult derivative to do by hand, given that we've got the calculator, let's get it to diff a function for us. And f dash x is equal to 12x cubed plus 12x squared, take away 24x for 1 mark. All right, so then state the two other turning points of f of x as coordinates. So there's our function. That one's labeled. We want this one and this one. And essentially what we're going to do is find out when the gradient of this function is equal to 0. And that's going to give us the x values. Bang those x values in for the y's. All right, so the way I'm going to do this one here, my notation is going to be f dash x equals 0. Then what we're going to do is jump over to the calculator and say the ants, or my derivative function. Let's go solve ants equals 0 for x. And what that basically does is it'll grab this, which is a and s, and let it equal to 0, solving for x. Right, there's our 3 turning points. Well, not our 3 turning points, but our 3 stationary points. So we've got an x equals -2, x equals 1, and we're going to have y equals and y equals. Now note, I'm ignoring x is equal to 0 because that's one of the ones that are already listed in this question, one of the other ones. So now what I'm going to do is bang in f of -2, which is -32, and f of 1, which is -5. All right, so this one here, that was -32. This one here was -5. We want coordinates. So let's go -2, -32, 1, -5. All right, now we want the range of this function. Well, what we've already found is this turning point here. We've got this one. All right, that one there is the -32. So that's going to be -32 there. And it's defined for all y values above -32. So we could say something like ran f is square brackets here, -32 up to +infinity. State the values of b for which the graph of y equals f of x plus b has no x-intercepts. So basically what we're going to do is grab this graph here and send it up b units. Now, how far would it go to produce no x-intercepts? Well, we're going to send it all the way up here, which is 32, but it's got to be more than 32. If I send it up 32 units exactly, I'm going to get 1 x-intercept. It's going to be there, okay? So what it's going to be is for values of b greater than 32. All right, let's just try that out. So what I'm going to do is say f of x plus 32. Okay, right, so what this should do is give us a new function, and I'm going to solve that when it's equal to 0, and I should get one solution only, one solution, and that is x is equal to -2. All right. Now that should happen. So what I'm going to do is grab this, and that should happen when it's equal to 0. So I'm going to do that with x is equal to -2 and confirming. Okay. So what that means is if b is equal to 32, we're going to get that 1 x-intercept, which is right there. So that point there will come up to there. So we need it to be greater than 32, not greater than and equal to. All right, we've got a tangent to f of x at x is equal to -1/3 is shown. The equation of the tangent is this, allegedly. So let's go ahead and do this. Now it's a show that, and it's worth a lot of marks, 3 marks. So let's start making sure that we're really showing what we're doing here. All right. So what I want to do is find out what the function is at x is equal to, was it 1/3 or negative 1/3? So f of negative 1/3 is equal to. I also want to find out what the gradient of the tangent is. So at f of negative 1/3. So let's find out both of these things on the calculator. So we've got f of negative 1/3. We're in decimals, so let's get out of that. And diff f of x with x is equal to negative 1/3. All right, so there's our two values there. So let's go and note that it was 80. Oh, no, that wasn't the right one. It was negative 13/9, and this one here was 80/9. All right, now what we're going to use is this great derivative, well, not derivative, but this great version of the gradient formula. Y take y1 equals mx take x1. Right, so we're going to sub in these points here. So these coordinates here, it's negative 1/3, negative 13/9, they're just points on this tangent line. So what we're going to say is we've got y take away negative 13/9, so y plus 13/9 equals m, which is 80/9 x take this one here, so x plus 1/3. Right, y equals 80/9x plus, what do we got, 80/27, take away this value here, 13/9, we're going to times that by 3, times that by 3, scroll down a bit, and we've got y equals 80x/9 plus 80/27, take away, what's that going to be, 39/27, and I'll be willing to bet that's going to be 41/27 as required. All right, the tangent intersects f of x at 2 other points. All right, so obviously it intersects here at the point of tangent, but it's going to intersect here and here. So what we're going to do is simply write f of x equals this tangent line. So we're going to look for the intersection of the original function and the equation of the tangent. All right, so let's go and get the calc to do the hard work for us. We're going to solve f of x equals 80x/9 plus 41/27 for x. All right, so there is the x is equal to negative 1/3. We know that these are the other two that we're interested in, though. These are the ones. All right. So what we're going to do is say x is equal to plus or minus root 42 take 1 all over 3, or just write it out like the calculator's got it. Either way, I was fine with that. All right, the graph of f of x is dilated by a factor of a half from the y-axis to become a new function. State the rule for g of x. All right. So what we've got is x comma y becomes the dilation factor half from y changes x. We're going to go half x, y stays the same. All right, so remember that's x dash and that's y dash. So x dash is equal to x on 2. That means that what we need to do is solve for x, because I'm going to put that into f of x, my original function, to form the new function. So that means I need to make x the subject. So x is going to be 2x dash. All right, so basically what I would have to do then is grab f of x equals blah, 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 whatever it is, and sub in 2x every time I saw x. Now, there's a really easy way to do this with notation. So all I'm going to do, Now, why I'm not bothering with y? Well, obviously, y dash equals y, that's unchanged, so I don't need to do anything there. So to form g of x, what I'm going to do is simply say that g of x is going to be f of 2x, because what I'm doing is jamming in 2x for every instance of x that I see. So again, this is going to be really quick to do on the calculator. Most of you guys who did it by hand got it wrong. So I'm going to do f of 2x, and there it is there. So g of x equals 48, x to the 4 plus 32 x to the 3, take away 48 x squared. All right, now this one was a toughie. Find the values of x for which f of x is greater than g of x. All right, so what I'm going to do is define a new function. So define g of x equals this thing here. All right, the dilated function. All right, now what I'm going to do is say f of x equals, let's do a solve, f of x equals g of x for x. All right, we get a whole heap of sort of solutions here. All right, and so this one's hard to see. So what I would do then is go, all right, so when is f of x, the original function, larger than g of x? Let's find out. So this is a great opportunity to use graph and table. Okay, right, so let's see, I've done a bit of earlier work here. In fact, I might just clear this stuff out. Okay, all right. So I know that my original function goes down to negative 32 from the early parts of this question. So I'm just going to drop it down. So my y min is negative, let's go 35 for argument's sake. Okay, all right, let's just see if f of x comes up. All right, there it is there. All right, now let's graph g of x and have a look. All right, so we can basically see that this blue function here is f of x, and it's larger than g of x there and there. All right, so what we need to get is this intersection point here and this intersection point here. All right, so we're going to get, an intersection there. Now, what's going to happen at 0, 0, the origin, is because a dilation at the origin doesn't do anything, the functions are going to be equal to each other at the origin. All right, so here goes. All right, let's head back to main and check out those answers there. All right, so there's obviously an intersection of the functions at x is equal to 0, but they're both 0 there. So what it's going to be, we're going to have, so x is an element of, we're going to go and say that it is negative 2 root 454 over 45, take 14 over 45. Now notice that I'm not including that point because the functions are actually equal to each other at the intersection point. This we want when this function is greater than. All right, and now that's going to go all the way to 0 and not include it, union with from 0 all the way up to that other solution there, which will be 2 root 454. Make sure that goes all the way over it, over 45. Take away 14 over 45. Not inclusive of it. So essentially what I've done here is I've just excluded 0 from the solutions between those two intersection points. So a very difficult question. Maybe only one or two of you guys got that one. All right, so here's another function. All right, well, does that look familiar? Why at part I are we doing this one here? Now that is exactly the same function as f of x, but the domain has been restricted. Okay, so what we're going to do is essentially have a look at the new f of x. So what I'm going to do is go to menu, graph and table, and graph f of x with a domain restriction, which is going to be from a half. Keyboard, where's those less than, no, less than and equal to. What am I doing with x greater than and equal to a half? All right, let's toggle that one off and let's graph this thing. All right, so there's my function. So for what values of x is h of x strictly increasing? Well, so it's going to increase or start increasing at this point here, which is the turning point. Now we already know this turning point from the previous question. I think it was like 1, -5. So it's actually going to be from here onwards, it's going to be strictly increasing. So it's going to be from 1 all the way to positive infinity. Okay. So that's when it's going to be strictly, oh geez, hang on. That's when it's strictly increasing. I want it when it's strictly decreasing. Ooh, okay. So that's going to be from this point here, which is the start of the function. That's from a half. And we're going to include that all the way up to and inclusive of the 0 gradient point 1. So that's when it's strictly decreasing. Ooh, bit of a mistake there. Anyway, never mind. All right, so it's from a half all the way up to x is equal to 1, because what happens at 1 is the function has a 0 gradient, and if it was over this side here, that 1 would be included as part of when it's strictly increasing, but on the other hand, it's also included when the function is strictly decreasing. All right, so what is the minimum value of h of x? Well, in this case here, it's going to be this turning point here, which again, we've worked out before. That's just -5 from a previous question. All right, so that was question 1. All right, this one here, rubbish skip being used in the demolition of the old science labs is in the shape of a prism with a cross section of a trapezium. Okay, so there's my trapezium we can see here, there, this part, and this part. Now, on your formula sheets, you'll have got the formula for area of a trapezium, which is area equals half a plus b h, all right, or some form of that anyway. That's on the VCAR U12 formula sheet, so make sure you look that one up, or like when you get a shape in these exams here, make sure you do have a look at the formula sheet and not sort of think, oh, I don't remember that one, so I can't answer the question. Usually we choose a shape for which there's a function or a formula on the formula sheet. All right, here we go. So show that the height of the bin is 12x. All right, so that's this thing here, the height, or this thing here. So it's all marked out quite nicely for us because what we've got is a triangle like so. That one there is 5x. That one there is 13x. Now, a couple of you guys from my class anyway recognize that that was a triad. That's the 5, 12, 13. Therefore, that must be 12x. But really, this is a show that. Okay, so you need to show it. All right, so my recommendation is to put this into Pythagoras' theorem. What I'm going to do is show you the way I would do this, or I'm going to use the method that a lot of you guys did, only because you really have to show this particular step. All right, I'm going to go c squared equals a squared plus b squared. All right, now the hypotenuse is given to us. That's 13x all squared. Very important, those brackets there. Equals a squared, which let's go 5x all squared plus b squared. All right, so we're going to say b squared is equal to, what is it going to be? 169x squared, take away 25x squared. All right, now what we're going to note is that we've got over here, we've got 144x squared is b squared. B is equal to, and it's really important that we do this mathematically. It's not correct to just assume that it's the positive solution. So we're going to say it's plus or minus 144x squared. B equals plus or minus 12x, but b is greater than 0, therefore b is equal to 12x. So must acknowledge the plus or minus solution there, girls. All right, show that a is equal to 6 take 10x. Where's a? There. All right, so they've told us what that is. Now, how do we know what a is? Up here. Okay, the base of the skip is a rectangle, length 4 meters, width of a. So that's that. That doesn't help us. The total length of the edges of the rectangular rim, that is the top of the skip. Okay, here it is. So this is 20 meters. So it's going to be this, all of this, this, and this is 20 meters. All right, so let's note that down. Oh, how am I going to do this? I need to see that picture. Okay, so I'm going to note that 20 is equal to the addition of all of these sides here, which is going to be 4 plus 4 plus, what's it, 5x plus 5x plus 5x plus 5x plus 5x over the other side, plus a plus a. All right, so that should become that. Let's just see what happens. 20 equals, what have I got? 8 plus 20x plus 2a. All right, we need to solve this for a, so I've got 12 equals 20x plus 2a. 2a equals 12 take 20x, div by 2, a equals 6 take 10x as required. Show that the area of the cross section of the skip is this area of the cross section. So this is the cross section. So yeah, all right, now here's where this formula comes into play. So area equals half a plus bh. So what I've got is I've worked out the height. I've got this part here and I know this part here. All right, so let's fill in what we know. So the area of a trapezium, area equals half a plus b. Right, so our a was the bottom, that was 4. Our b was 4 with 2 lots of 5x on it, so that's 10x, multiplied by the height, which we worked out in part A, was 12x. All right. So what we want to have happen here is that this becomes this. Area equals, so I'm going to halve the 12x, so I'm going to say that that's 6x, 8 plus 10x, area equals 48x plus 60x squared. That would have been fine, but I just like to get it exactly what's required. 48x as required. Hence, show that the volume of the skip in meters cubed is given by this. So the volume is the area of the cross section multiplied by the height or depth or whatever you want to call it. Area equals, so we've got the cross section here, 60x squared plus 48x multiplied by the depth. That's this thing here, which is A, but we know A is already, we've worked that out, it's that value there, 60 take 10x. Okay, and what I would do is show an expansion of that. So I would include a line that shows the expansion of that. I'm not going to actually do it because this video is going to get dreadfully long. but we're going to assume that when expanded, it becomes 288x take 120 x squared take 600 x cubed. Find the value of x for which the volume of the skip is a maximum. Okay, so now we've got this volume function. Show that the volume of the skip. So find the value of x. So this is the volume function, so let's define it. Okay, so find the value of x for which the volume of the skip is a maximum. So we're going to diff f of x, which that's the derivative. All right, so let's go whoop, come on, you're gonna, oh, I was writing with the wrong end of the pen there. Okay, let v equal f of x. Okay, so now I'm gonna say f dash x equals negative 1800 x squared take 240 x plus 288. All right. Now what we're going to do is say f dash x equals 0 because that's where the maximum is going to occur, is at a 0 gradient point. So we're going to say solve hence equals 0 for x. Right, and we've got two solutions here. So x is equal to plus or minus root 37 on 15 take 1 over 15. But this negative one here is a minimum, okay? So even though f dash x is equal to 0, the maximum, but max occurs at x is equal to root 37 on 15, take 1 on 15. All right, it has to occur at the positive. It can't, the maximum can't occur at a negative value of x. All right, think about it. Right, like if it could be negative, that means 13 multiplied by a negative number. That means this side length is negative. No, it's positive. All right. Find the max vol of the skip correct to 3 decimal places. Well, I know the max occurs here, and I know f of x is defined as the volume function. So all I'm going to do is I'm going to go f of root 37 on 15, take away 1 on 15 to find out what the max volume is, and it wants it to 3 decimal places. All right, over to the calc. F of x, not f of x, f of, just grab the positive one, chuck it in, and we get this sort of pretty ugly number. You can see why we went to 3dp on that. All right, let's try it again. There it is. So 3dp on that is equal to 60.4665. Therefore, 60.46, what is it? 467 meters cubed. Find the rate of change of V when x is equal to a fifth. So what we've got to do is diff f of x and sub in x is equal to 1/5. All right, so the rate of change, so we're going to say f dash 1/5 is equal to 168. Therefore, 168 meters cubed. What's the rate? Meters cubed. Volume meters cubed. What's x? X is in meters. So volume equals 168 meters cubed per meter. All right, question 3, flying. There we go. Ooh, not flying. Half an hour in. All right. Well done to those of you who made it this far. Okay, we've got this Joanie Garden purchases a hose reel. There's a handle to wind up a hose. All right. So let's define this function here. So define f of x equals 40 plus 15 multiplied by cosine shift pi times x. All right, has got a domain restriction. I'm not going to put it in, I'm just going to go for it. Okay, state the min and max heights of P above the ground. All right, so here's where sort of like a pretty sort of crap sketch is going to come in handy. All right, so what we've got here is we've got the translation 40, it's going to go up to 55, down to what's 40, 30, 25, down to there, so that's the mean. And what is it? We've got cosine, and it's an upright cosine. So it's sort of going to go like this. All right. So that means that the max is going to be 55 meters and the min is meters. What? No way. Centimeters. And the min is going to be 25 centimeters. How high above the ground is the knob when Jared starts winding? The knob is at point P. All right. Well, we're not going to assume that that's the position. So let me just go and note that that's going to occur when I bang 0 into the function. So f of 0 equals 55. Therefore, 55 cm. What's the mean? Oh, yep, already got that. Got the picture already. That is going to be 40 centimeters. Yeah. How long does it take Jared to wind the handle for one complete revolution? That's the period. One revolution is the period. So that's that to there. So for a standard cosine function, the period is 2 pi, and let's just divide it by pi. Whoop, whoop, whoop. What happened there? They cancel out, equals 2, therefore 2 seconds. Jared starts winding the handle and stops after 10 seconds. How many revolutions? So if it takes 2 seconds to do one revolution, let's do 10 divided by 2 is equal to 5. 5 revs. How far above the ground, corrected 2 decimal places, is the knob after 8.6 seconds of winding? Let's just do h of 8.6 and find out. So f of 8.6, we're in decimal mode. That sounds reasonable. 53 point. Ooh, we're in degrees. Yeek. Okay, that's dangerous, isn't it? Look at that. So only by the grace of God did I quickly look that I'm in degrees mode there, because that's a perfectly reasonable answer. All right, so let's just drop that into radians and note that it's going to be 35.3647. How many dPs? 2 dPs, therefore 35.36 cm. Nearly got or came unstuck by that one. For how long, corrected 2 decimal places, is the knob at most 30 centimeters above the ground during the 10 seconds? All right, so here's what's happening. At most 30. So here's 30 along here. All right, so at most 30, that's at its highest. All right, so basically we're looking for this bit here, and another 3 bits of that going along. All right, so we want to know, because what's going to happen is it's at most 30. That's what we're going to allow it to get to, at most 30. All right. So think about the language here, because this is the thing I think that you guys messed up with this one here, is you didn't understand what at most 30. All right. Now, if I said to you, to pay me for, a lesson that I taught, and at most I'll accept $30, that's the largest I'm going to accept. I'll accept anything below it, $10, $5, 2 cents. Hell, I'll accept zero. All right, I'll have to, because I said you're going to pay me at most 30. All right, so let's find out. So I'm going to go solve f of x equals 30 for x. And what I'm going to get is, I just want one solution. All right, so I'm going to restrict, because what's going to happen, okay, so I'll just do this, right, and what we get is the general solution. So what I'm going to say is, hey, can you just give me one solution that is between 0 and 2? All right, so what happens is it's going to hit 30 there and there. All right, so here's my notation. So what I'm going to say is h of t equals 30, where t is an element from 0 to 2. T is equal to 1.2677 dot, dot, dot. T is equal to 0.732 dot, 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 dot. Okay, so what I'm going to do is now grab these two values. So this one, take this one. All right, and that's how long it's basically going to be below 30 centimeters. All right, so what I'm going to do is 1.266, one of them, 77 dot dot dot, take away 0.732 dot 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 dot, and we're going to have one instance there, but what happens is it's happened over the 10 seconds, which is 5 revolutions. So what I'm going to do is multiply that by 5. All right, so back over to the calc. Let's times that by 5, and it's going to be to 2 decimal places, 2.68 seconds. Difficult question. How far above the ground is the knob when Jared finishes winding the hose completely? That's at the end point of the domain, which is 47 from memory. Yep. So that's going to be h of 47 equals 25, therefore 25 cm. All right, question 4. The Joanie garden has been a raging success, and now they are researching composting techniques. 2 bins filled to the same height with composting material, then different composting techniques are used on each bin. Okay, what's the height? Okay, all right. Many of you guys buggered up this first question here. Just be careful with exponential functions. All right, so what's the height of the material in the bin? What I'm going to do is define a function, and this function here has got a k value in it. All right, well, can I be a bit crazy? I'm not going to answer this question yet. What I'm going to do is show that, I've just noticed here that part B says, show that for bin A, k is equal to 0.2. So the k value is 0.2. Let's do that first, then define the function, then get the height. We could still do it, but anyway, let's just do that. Right, so 5 weeks, where t is in weeks, 58. So 58 equals 140 times 5 to the negative k5, is it? 5, yeah, plus 30. All right, that's going to be 28 equals 140 times 5, negative 5k. 28 over 140 equals 5 to the negative 5k. If you did this on the calc, you'll note that it simplifies down to a fifth. Numbers carefully manufactured there. Now, some of you guys started taking logs of both sides here. This one here, we just want to equate the bases. So that's going to be 5 to the negative 1 equals 5 to the negative 5k. Negative 1 equals negative 5k. After equating the bases, k is equal to 1/5. Right, now let's define our function. Define f of x equals 140 times 5 to the power of negative 0.2 multiplied by t, okay, x plus 30. All right, let's answer the first question, which is f of 0. So h of 0 is equal to 170. Therefore, 170, that's got to be centimeters. So we want to sketch the graph of this. So it's 170, asymptotic behavior at 30. It's going to be hard for me to do on this thing here. I'm just, oh god. Okay. So you need to just grab your ruler at this point here and make sure that okay, our variable is h, so it's h equals 30, the asymptote. All right, and what info do we know? 5 weeks is 58. So there's 15, there is 10, there is 5 roughly. So get close to 58 there and send it through there and get it to run so along there. So that is just an appalling graph. 0, 170. So you guys got to do a lot better than that. I've just got this stylus pad in front of me. I can't draw graphs to save my soul on this thing. So what's going to happen is going to be a nice smooth curve going through that point here, coming down along the asymptote. Never make it look like it's heading towards it. So if you draw it like that, that looks like it's going to cut the asymptote. Okay, so it's going to head along it, but not cut it. All right. Average rate of change. All right, so the average rate of change is simply the gradient. So average is equal to h of 20, take away h of 10, all over 20 take 10. Slam that into the calculator. All right, that's going to be, so let's go shift divide, f of 20, take away f of 10, all over 10. And it's the exact value. We could convert that to a fraction or just 7.6. And what is the rate? Centimeters per week. Instantaneous rate of change of the height. So we're going to derive an exponential function. Now, year 11 level, you wouldn't have a clue how to do that, but this is calculator, right? So what we're going to do is say h-8 equals. So let's diff it. I'm going to diff f of x, which is that, with x equals 8. There it is there. It is to 3 decimal places, negative 3.431 centimeters per week. Okay, bin BK. All right, this one here, let's define a new function. So define g of x equals 140 times 5 to the power of negative 0.4 times x plus 30. All right, so find the height of the material. So we're going to do g of 5. So we're going to say h2 5 is equal to 35.6 cm. Find the max difference correct to the nearest centimetre between the heights of material A and material B over the first 6 weeks. Many of you guys just did H2 of 6, take away H of 6, and assume that the biggest difference would be after 6 weeks, but it's not, okay? So what we're looking for this one is maybe a table or some sort of trial and error, but the reality is it happens. So I just know this from memory. If I do f of 3 take away g of 3, was it 2 weeks? I can't remember. F of 2 take away g of 2. Oh, it was after 2 weeks. So you had to sort of show some trial and error, but ultimately it was going to be h of 2 take away, not g, h, what's that new function called? h2 of 2 equals 34.91 ... correct to the nearest centimetre, therefore 34 centimetres. There's a pretty cool way you can do this as well. F of x take away g of x. We write a new function. All right, so I'm going to define h of x as this new function. All right, now check this out. What we're going to do is diff h of x. All right, who cares what it is? All right, that doesn't matter. Now we're going to solve that. Solve the answer equals 0 for x. All right, now, if you understand what's happened there is it's basically formed a new function, which is the difference of two functions. And then what you can do is treat that as just one function, which represents the difference of two functions, and then say, hey, I just want to graph that and find out when it's at its maximum. Okay, so you essentially are finding out when the gradient of that function is 0, that is when the height is at its maximum or maximum difference, and that happens at exactly at time 2.15 blah blah blah. So you could have answered like that. We weren't expecting you to do that, but that's a cool way to answer that one. All right, up to the last question, 47 minutes, not too bad. All right, consider f of x when h, oh, this was the mistake. Yeah, now I screen dumped the wrong function in there, and I had negative 2x plus 1. So that rendered a little bit of this question incorrect. It's a bit annoying that, but I am human. Anyway, this is the corrected version of it because, yeah, I didn't want that to be left like that. All right, so consider f of x when h is equal to 1. All right, so that's what we're doing first, is we're saying, hey, h is 1. All right, now what we've got here is find f of negative 1. So we've got to put negative 1 into this function, but only one of these actually accepts it. This one's not going to accept it because this is for values of x less than negative 1. All right, so it's got to go into here. So f negative 1 is equal to negative 1 squared, take away 2 times negative 1, take away 2. And that's, what's that going to be? That's going to be 1 plus 2, which is 3. 3 take away 2 is 1. Right, show that it's not continuous at x is equal to negative 1. So there's a discontinuity there. So essentially what's going to happen at x is equal to 1 is we're going to have, if I put 1 in here, I'm going to say that that's going to be negative 2, negative 1. It's going to do something like that, right? And then we've got a parabola. All right, let's just see what happens. All right. So what I'm going to do is go and test the limit on either side of negative 1. So let's go the lim as x approaches 1 from, let's go in from, well, let's go in from the right-hand side. So from this way, from the parabola. Lim as x approaches 1 from the right-hand side for the function is equal to, well, we already know that approaches 1. let's go the limit as x approaches 1 from the left-hand side for the function. So what we're going to do is put that into this function here. So that's going to be, when I put 1 in, oh, negative 1, negative 1. Negative 1 approaches negative 1 from the left, approaches negative 1 from the right. I thought that graph looked terrible. No, it should be negative 1. It should be over this side. Anyway, negative 1 from the left, negative 2 times negative 1 is 2. 2 plus 1 is 3. All right, now notice that when we swing in from the right, we approach 1. When we swing in from the left, we approach 3, i.e. we don't approach the same value. So that means that we have got a discontinuity. So what I'm going to do is just summarize that in a statement. I'm going to say the limit as x approaches negative 1 from the right for the function is not equal to the limit as x approaches negative 1 from the left for the function. Therefore, the limit does not exist, and also, and function is not continuous at x equal negative 1. Okay, so for what value of h will f of x be a continuous function? All right, so why is it scrolling up? Okay, now, all right, I think what we should do is have a look at this. All right, so what I'm going to do is define f of x why isn't it letting me type? I'm just going to pause this for a second. All right, yeah, let's keep going. All right, so define f of x equals. Now, what you can do is in Math 3, you've got this cool template that you can use to write some hybrid functions. So 2x plus 1, where x is less than negative 1. And this one here, we've got the parabola x squared take 2, x take 2, where x is greater than negative 1. Right, let's have a look. Okay, so that confirms our suspicions that we do have a discontinuity. And what we've got to do is for part C, we have to scrap this question on your paper, but we're going to say that h, if we can vary it, what we would do is drop it down. Okay, now how far? Well, this endpoint here, we've just ascertained that that's going to be at 1. So at the same point, this function was 3. So what we need to do is drop it down 2 units. So this one here would be negative 2x take 1. Okay, so if this was take 1, that would be dropped down 2 units. So I suspect that it's going to be h is equal to negative 1. Let's just try it out. So we're going to go back in here and say it's take 1. So we redefine it. You've got to hit enter on that to make sure it redefines it. Let's go back into graph and table, regraph function. Hello, continuous function. All right, state this in turning point form. So just quickly do a complete the square on that. So we've got y equals x squared take 2x halve it square add it. So we've got halve it, which is 1, square it, which is 1 squared, take 1, take 2, y equals x take 1, all squared, take 3. Okay, So that's incomplete the square or turning point form. Right, another piecewise to function is this, x take 1 plus 1, this k value here, which is this function here. Is that the same function as that? X squared take 2, x take 2, x squared take 2, x take 2. All right, so let's go back, main. Let's change that back to plus 1. And let's go back, graph this thing. All right, yep, I can see what's happening here. So once we know the turning point, we know the turning point was, or previously was 2 below, right? What we can do is just bump that up 1 and 1, and what that should do, so we're going to lift it up 2 units. So this value here, this k value here, should be k is equal to -1. So what I'm doing here is I'm noting that this k value here will be 2 more units up from -3. So that's going to be -1 to lift it up. Now let's just see whether that works. Again, I'm just flicking around here. I'm going to change this to be x take 1 all squared. And I believe take 1 should do it. Let's have a look. Bang, continuous function. All right, that's the end of that section there. I'll record another video doing the multiple choice. Yeah, some other time.